Okay, we have the recording going. It seems to be Wednesday, February 15th, day after Valentine's Day. And we're moving forward today into Module 6, the title of which is Conditional Structures. And I'd like to underline the word structures. There is a lot of structure in these things. And that also means there's a lot of different ways of doing things. And oh, there we go. Now we have enough. There's a lot of different ways of doing conditional structures, and there's also a great opportunity for really messing things up. So the reason that this needs to be studied and practiced is, and you can probably guess where I'm going, it gives you a great opportunity to do one of these. So this is what happens if you don't create a structure, whether it's an iterative structure, a conditional structure, or a data structure. If you don't think it through beforehand, you can quite end up like the poor deputy with just a stack of things going on. So we're going to try not to do that. And I'm going to hang in there pretty close to the D2L material for the start today, just because it's so fundamental and so important that you see what's there. All of this is mentioned in the cheat sheet, of course, not in a lot of detail, but it's basically all there. So before we do that, any outstanding questions on assignment 5, which is coming up? Or are you guys good? All right. So just to keep score on assignment 4, I received 6 out of 17 submissions. All of them passed. 5 out of the 6 were quite good, maybe 4 out of 6. Anyway, the key is that those 6 people are on their way to completing the work in the class. And I guess if I can get my subtraction right, the other 11 are not. So the word is out there. Let's go back and just take a quick check-in. Not here. Let's take a quick check-in on what's going on in the course. I got rid of some of the garbage in the announcements. The couple of points I'd like to make on the record is that there are Zoom sessions recorded, and they are available in a YouTube playlist, and they're linked into D2L. The other thing I'd like to repeat is that help is available. You can book slots on You Can Book Me, and I will be happy once we figure out a mutually convenient time to go one-on-one with you in a Zoom session, and multiple sessions if necessary. So, you know, I not being on campus, I don't have office hours. I can't do face-to-face tutoring, but I can certainly help people out on Zoom sessions. So far, no one's taken advantage of that. Usually there's 1 or 2 students who take a lot of advantage of that. And even if they're not strong in the course, it tends to be enough to pull them through. So just knowing that you don't know something just isn't very productive. You know, that if that's as far as it goes, I don't know how to do this. I don't understand the errors I'm getting. Not very productive. You really need to work with somebody or some resource to get you unstuck. And then you move on to the next place you got stuck. So that's in general the process. I get stuck, I fix it, I move ahead. That part's easy, next part comes up. So no new news down here. Assignment 5 is coming up next. And then in a week after, we have a project, which is a big deal, and the final project proposal that I will probably talk about later in the class today. I do have a breakout exercise for you as everybody runs to hit the sign off button. It's on conditional structures, and it's a good example of plan first and write second. there's at least 3 very distinct ways that you could approach the breakout exercise. I don't think it's a very hard one, but let's see what you have to say, assuming there's at least 2 people to participate. All righty. So, as I said, we are formally moving into Module 6, conditional structures. So classically, conditional structures mean if else, and if else. That is the basis virtually in any language for conditional structures. Most languages extend that concept into something that I've always liked called a switch statement, particularly in Java. It's the same concept, it just looks different. And I think it looks cleaner, easier to read, easier to maintain. So this is a little bit of historical perspective. Guido van Rossum, the author of Python, when faced with the challenge about why doesn't Python have a switch statement, his answer was because it doesn't need one. And as long as he was benevolent dictator of Python for life, that was the way things were. As he moved on from the position of benevolent dictator for life, committees of people giving their inputs into the future of Python decided that while we don't need it, it's a good addition. So only as of Python 3.10, which should be what virtually all of you are running. In Python 3.10, we have a new conditional structure called match case. It is in essence a switch, as those of you who will take Java later will find out. So we're just going to spend some time looking at it. It's new, it's not in the course, and it lets you build your structures in a different way than if you didn't have it before. So, talking about the basics, starting with an if. It's very important in planning your structure that you figure out what it is what is it that you need to do. Without the plan, you're going to end up with the pile of horses and men and guns. So let's go down the, 4 possibilities, one at a time. An if statement, just by itself, is a one-way test. If it is raining, this is what I'm going to do. If it's Tuesday, this is what I'm going to do. If my grade is less than 70, this is what I'm going to do. So if you have a one-way thing to test, you can write an if statement. After that if statement must come some kind of a test. And we'll talk about that here when we talk about relational and logical operators. The test can be simple, the test can be complex, but there must be a test, and the test must evaluate to true or false. I think we found out last time that there are strange things that also evaluate to true or false. For instance, an empty string, the name of an empty string has the value of false. The name of an empty list, dictionary set, or tuple has the value of false. If there's anything in the string, including a space, anything in any of those data collections, at least one, then the name of the object, the data collection, will be true. In general, languages tend to treat 0 as false and anything else as true. That's a hard way to approach things, by figuring out that and how they use it. Is it just a +1 or -1 that it uses? You don't really need those concepts. You do need the concept of the built-in Python object true with a capital T and false with a capital F. So those 2 objects have the values that you'd expect. So that's another thing that we're going to look at. So a one-way decision, if. Two-way decision, if else. if it is a weekday, I'm going to work, else I'm staying home or not going to work. So if you actively have something to do in both the positive and the negative case, and there are only two cases, then that's an if-else. Now, since it either is or isn't the weekend, after you get done identifying in the if statement that it's a weekday, then anything that's left under the else is the weekend. Therefore, the else never has a condition after it. And as a matter of fact, it can't have a condition after it. So two-way, is the switch on, do this, else do that. Do not say, if the switch is on, do this, else if the switch is off, do that. Do not say, if the switch is on, do this, if the switch is off, do that. That just leads you down the road of more code than you need, and also possibly some side effects that you weren't looking for. So two-way is if-else. Well, next up is a multi-way. And that's where sometimes we wish we had a switch or a match, and now we do. So the multi-way is if followed by one or more elifs. And elif, as you can guess, is an abbreviation for else if. In Java, there is no elif or else if. There's else space if. So Java just kind of makes it into a visual trick of separating an if and an else with a space. So in your elifs, you can do multiple things. Of course, one elif per thing that you're trying to do. So elif is another one that must be followed by a test that evaluates, or an expression that evaluates true and false. Well, the last case, I'll call a multi-way with a default. I have a bunch of things that I'm testing, but there's a possibility that none of them are true. So, but I want to take action in any situation. I want to cover all the bases. So I write an if for the first condition. I write an elif for the next condition. I write an elif for the next condition, et cetera, and then I write an else. And the else will pick up the fact that all of the ifs and elifs all were false. So in other words, it's a default. And that covers all these situations. You know, it's either one of these or maybe it's none of them. And I've got the code to match both of them. Okay, any questions so far? So let's see how this becomes complicated. And it really does. That's why this is a section unto itself. So every language has pretty much the same relational operators. This is how do you compare things? Are these things true or false? Well, you can see here that that's the only possibility. Whatever you're doing in this test is either true or false. Of course, it's very important to note that the equal to is not an equal sign. It's a double equal sign with no space, because the equal sign has already been taken up with the assignment operator. So you can't use an assignment operator as a logical test. So the difference is assignments are in equals. A test of equality is equals equals. And then, of course, the rest of these are not surprising. Less than, greater than. Less than equals with no space in between, and the less than must come first. Greater than or equal to, no space in between. The greater than comes first. Not equal to, no space in between. The exclamation comes first. So the operator in these cases is literally not equal. Exclamation followed by an equal. And then this kind of goes and explains all of that again. So just in case we don't have enough flexibility in building these things, we have three logical operators. Again, very, very typical. I guess every language must have these operators, even if they're not written the same way. So our operators are and in lowercase, means all of the conditions must be true. Or, of course, means at least one condition must be true to get a true out of it. And not is a flip. If you give it true, not will give you false. If you give it false, not will give you true. So these can be combined in any which way you want. There's some order of operations, which if you're not comfortable with, just use parentheses to group these things. So once again, here's our trip to Home Depot. We have a lot of tools that we've already covered. We have kind of 4 different ways of writing a conditional structure so far. We have however many operators we have here, looks like 6 operators. And we have ways of connecting tests with ands, ors, and nots. So considerable flexibility and considerable opportunity for not thinking it out first. So if you think it out first, and I'm terribly old-fashioned, I usually think it out on pencil and paper and little sketches, then it'll work. So let's see what's next. This kind of makes the point. Probably there's nothing new here, but we'll just do it as repetition. So this is a basic if-else. It is a little different than that. You don't need the else. So in this case, the only thing you're interested in is the temperature being greater than or equal to 60. If it's less than 60, what do? I don't know, and I don't care. So this is a one-way test. Two-way test, I do care. If it's greater than 60, woohoo. If not, then something else is going to happen. It's worth noting while we're here that this is another approach to having quotes inside of quotes. Last time, I think it was last time, we said that if you need quotes inside of quotes, if this needs to be an apostrophe, then make this a double quote. Conversely, if you need a double quote, then make these single quotes. Well, the other way of doing it is to use a backslash before the single quote. And that's in a string manipulation. The phrase is it escapes the meaning of the next character. It says that the next character is not to be treated as an important syntax, it's just to be treated as a character. So doing that with the single quote makes it okay. It looks a little clunky. I would rather not do this and just put the whole thing in double quotes. So there are 2 other uses for backslash we've talked about. One is \n. Of course, n has no special meaning, but \n means go to the next line. And \t is a tab. I think there are others, but I don't think you come up very often, not very important. So don't write more than you need. If you just need a single test, do it and you're done. You need 2 tests, if and else. I'll show you a little later that a simple if-else has, there's a way in Python of kind of writing it all in one line. So that will be kind of interesting. I don't think that's mentioned in the material. And here's an example. What are you going to do under what condition? And here's the thing about the physical simulator. You can certainly do that on your own. What we see here is there's an infinite loop and a test. So, conditional statements, it's all about the test. What is the test? Well, the test is to look at the value returned from button number 1 and testing whether that value is equal to the string pressed. Now, that's a bizarre thing for a button to return, but that's what you get with the physical simulator. In GUI 0, you just never do it that way. That's not cool. And in the physical simulator, it's magic. When the button is pressed, there's a momentary press event. So if your program comes back sometime later and asks, is the button pressed? The answer is probably no. But the physical simulator software has some things in it to make that work. And here you see an example of what not to do. It's a while true loop with no delay in it. So don't do that. Indented once in the loop outside of any conditional should be a nominal sleep, even if it's a 1/10 of a second. Okay. And of course, this code is available to you. So can we combine them? Yes. We can combine them into 2 tests in one line. So it isn't multi-way. It's a one-way multi-condition test. And what are we finding out? We're finding out, is the temperature greater than or equal to 70, and is the light on? So you can guess that it'll do the right thing in terms of order and operation. It will evaluate this. It will evaluate this, and then it will combine them with an and. And let me see what we got over here. Okay. Does that make sense? Combine it, take one test and combine it with a second test, or a third, or a fourth, or throw the word or in there. Make it as complicated as you want. All right, cool, we're good? All right, is anybody alive? Somebody go, ooh.
Ooh.
Thank you. Okay, it's cool, but it's not true. Sorry, but then there's some explanation here that kind of explains what happens here that can fool you. So what has to be true for and to be true in English?
Both of them have to be true.
Right, both of them have to be true. So what do I know about the and if the first one is false? Do I care about the second one?
No, because it doesn't matter.
Doesn't matter. So that's referred to, at least in other languages, I guess, in Python also, it's referred to as short circuit evaluation. If you've already made your point, if temp is not greater than or equal to 70, don't do the rest of it. It's the opposite way around with an or. Once I find something being true, I don't do the rest of it. And that can get tricky. And there are several ways around it, but we'll talk more about that later. So just recognize that without you doing anything else, that the second condition may not be evaluated if the first one is false, which is good for efficiency, but depends on what you're trying to get done. And then they've got examples of the code there. All right, moving right along. So here, as we've said before, is the general form. The most critical thing here is to note that if must have an expression, elif must have an expression, and else may not have an exception, an expression. So else is your default, your cleanup. These parentheses should not be here, although Python will accept them. It's not Python style. So down here, you can see there are no parentheses. So if we just look at this example over here, we can see where things get a little tricky. So the first question we ask is it chilly out? Is the temperature less than 70? Well, if it is, it's probably not great beach weather. Then we find out, is the temperature less than or equal to 80? And if it is, it's super duper good beach weather. And then in this case, else it's really hot out. Well, if it's really hot out, it's probably good beach weather, but I didn't write this, so don't blame me. So we've covered these things in a very specific order. This rules out, or this catches everything less than 70. This will, therefore, this catches things between 70 and 80. And this, by default, catches everything over 80. So you don't need, you can't put a test here. You probably should not be putting an ELIF there because it's redundant. So again, structure, structure, structure. And you can't do these things, in this case, you can't do it out of order. If you tested for less than equal to 80 first, then there's no point in testing for 70 after that. So the order in which you test is important. The way you usually see these things is in taking a numeric grade and matching it up to a letter grade. That's the similar kind of thing of having to go in the correct order. Did you get over 90 or above, then you got an A. Now that you've handled that, then find out if you got an 80 or above, and then you'd get a B. And if you didn't get an A or a B or a C, then you didn't pass. So similar idea. Okay, what else do we need to talk about here? I would say not much. I'm going to leave you, if you want to read these things on your own, this you can kind of see the same concept. Now, looking at this concept, this little bell should go off in your head about assignment number 5. This is the concept of taking a range, breaking it up into different sections, and doing something in each section. So, does not mean you should copy this code and paste it into assignment 5. That's not the key to success. But this is one way of looking at it and one way of doing it. And you can, the rest of it you can kind of read on your own. Python has, as far as I know, a unique feature, and I just love it. I think it's a great syntax assistance to me. And that's to take something like this and recognize that we're comparing the same variable temp against 2 different numbers. And if you look at that long enough, you'll notice that we're comparing them within a range. Basically, what we're saying is the temperature between 33 and 50? So the key to any language, programming language, is how can I say that with the least amount of typing? So in this case, I've got 2 comparisons. I've got an and Python gives you a beautiful way of saying exactly the same thing. You put your variable in the middle. You put your less than equal to here. You put your low limit here. Your less than equal to here. You put your high limit here. And if you read it carefully, these things are going in the right direction. So this says, is the temperature greater or equal to 33? And is it also less than equal to 50? So this combines all the logic here in one easy to read, simpler line. It doesn't have to be inclusive of those ranges. So you could have a less than, not less than equal. One could be inclusive, the other doesn't have to be inclusive. So whatever you want. But if you write it like this, with your lower limit here and your upper limit here, your variable in between, it's all good. PyCharm is smart enough to know that this exists. So if you write that, it will say, this is overly complicated. Would you simplify it for me? And you could. Okay. So any place there's a question here, just shout out. Okay. So we know that if, elif, and else are all keywords that define a software container. How do we know that what we're looking at with if, elif, and else is a software container? Two important clues. Oh my. How do we recognize a keyword that contains code underneath it? Okay,
Can you ask that one more time?
yes. We have a lot of keywords in Python. Some of them define containers for software. So it underneath those keywords, we have one or more statements that are part of the container. And there's a big clue, two big clues when that's happening. So take a look at if, elif, and else and see if you can give me one of the two clues.
Indentation.
Indentation is the one clue, one more.
I don't know that other one.
Okay, the other one's the colon. All of the ones that are starts of containers have a colon at the end, particularly def. We've used def a lot. And if and for, all of those are keywords that start a software container, and the indentation then follows. So where we go from there is that just like either your Tupperware, or I think they're called Russian stacking dolls, you can certainly put one inside another, inside another, inside another. There's nothing that says you can't do that, and you can. When you do that, you just have another container like this and another indentation. So where this is indented once, this line here is indented twice. So structure again, code structure, not decision conditional structure or looping structure. The code structure in Python is built with colons and indentation, and there's almost no rules about what can be inside of something else. Maybe by the time you get to objects, you might find some rules. Now there's some implications, like in GUI 0, we used inner functions. More about that in the next section. So what this says is that if you convince yourself that you need a nested structure of ifs, elifs, and elses in any variety, then just do it. Just make sure that your structure in Python reflects what you want done in English. So you have to be able to read through these things and come up, well, ideally come up with a plan first and then the structure afterwards, and then go ahead and write it. So this is the statement that I execute if branch 1 is true. If branch 1 is true, I then go to presumably a different expression, test it. In other words, where my highlight is now will get executed if this expression is true and that expression is true. So I used a keyword that I could have used to build the structure. I could have said that. This example didn't do that. They had an if indented in an if. The result of an if indented in an if is to combine them as a logical and, making this execute only if this and this are true. This is one way of avoiding short circuit evaluation. So there is no multiple conditions here. There is no and here. So we're guaranteed this test is going to happen and this test is going to happen. These can get quite complex. So, and it's always based on indentation. If, elif, else, under the if is an if and an else. Under this else is an if, elif, else. So PyCharm is going to help you out with a light gray vertical line to help you line these things up. If you go in and change the indentation which you might need to do for good reason, you've changed the meaning. So how do we know that this else belongs to this if? And the answer is they're both indented the same. We move this else back to here, then we've got a problem. This if matches the else, and the elif can't do that. So very, very critical in how the things are indented. And again, there's an example over here. All right, I think I need to take the opportunity to be critical of the example. There's a lot of indentation going on here. And the more indentation there is, and the more levels of indentation that there are, the harder it is to figure out what's going on. I haven't looked at this in great detail, but it looks to me like it's just splitting things up into different ranges. And doing it with this nesting seems like the hard way to do it. I assume it does what it's supposed to do. But, you know, as we'll see in the breakout exercise, think first, write second is a big key. All right, let's see. Are we almost at the end of this? Feels like it. Yes, yes, we are. So one of the things, and notice we've kind of done together what you could do on your own, which is go through the D2L material and learn it. You know, that's what the pure online asynchronous sections are about. You don't have to listen to my whiny voice explaining things. You just sit down with this and you go through it. Including these practice sections. So in the practice section, what they do is they lay out a problem. They give you a video showing you the solution, and they give you code. Well, gosh darn, if we're giving you code for this section, you can use it for whatever you want, not by copying and pasting, but by looking at the concepts. And if you look at this, you'll notice that there are actually 3 solutions out here. So how can there be 3 solutions to one assignment? And the answer is easy. The deeper we get into this course, the more you're going to see that there are multiple ways of solving exactly the same thing. And definitely a way of arguing which is better. Some of it is personal preference, some of it is style, some of it is, maybe experience. But as we move forward, it's very unlikely that 2 of you are going to come up with exactly the same solution to an assignment. Now, if it happens to be the wrong solution to the assignment, then the odds are much different. There is very, very, very little chance you both came up with the same wrong solution. And as I've told you last semester, when 4 students came up with the same wrong solution, the probability of that was 0.0001%. Although none of them understood how it possibly could have happened. They all 4 did not come up with the same wrong solution. So we've got these here. And you can go over them and we can go over them. I think what I'd like to do though is something else. I think I would like to spend some time going over match case with you. So let's put this away for the time being. And let's go over here. And let's take a look at the start of a program, because I was lazy and I didn't want to type. Okay, so first thing to note, if you don't have Python 3.10 or later, this will not work because it's going to use a keyword that didn't exist prior to that. So we're going to ask the person to type in, we're going to ask the person to type in what programming language do they want to learn. To do that, we're going to give him a hint over here of here are some languages you might be interested in. To do that, because we want to limit their creativity in typing things in, we're going to make a list of languages that we're going to respond to. And what type of variable is languages? This is a repeat question. Is it a string? Okay, even if you don't know, PyCharm knows. I can hover over it and it says, well, languages is a tuple. And by the way, it is composed of however many strings I have there, 7, 8, whatever. It's a tuple composed of strings. So if PyCharm can figure it out, you should be able to figure it out too. It's a tuple because it's a comma-separated list of things without anything around it. I could have used parentheses and that would be the same thing. If I used square brackets, I would be making a list, not a tuple. If I used curly braces, I would be making a set out of keywords. And if I used curly braces with key value pairs, I'd be making a dictionary. Now that's fundamental. You have to understand what these variables are so that you use them intelligently. So since languages is a tuple, that makes it something that is iterable. And that's why for loops or for in loops exist. They exist to navigate through things that are iterable, like tuples, lists, dictionaries, sets. Strings are iterable. And range as a function generates a range of iterable integers. So all those things are iterable and can be used appropriately. Since all I want to do here is I want to print out a list of languages, I'm going to define this up here so it stands out. I'm going to make my variable name all in caps, implying that the program is never going to change it, implying but not demanding that it be a constant. Although Python doesn't officially have constants, that's its convention. So the topic or the module we're moving away from on iterations, hopefully for language in languages makes sense to you. I'm just going to print out each of the languages with a space. And when I'm done, I'm going to go to the next line. And then I'm going to skip another line. And I'm going to ask the user, what programming language do you want to learn? So they only get one shot at it, and there's no loop in here. So now we have a reply. Any questions so far? So far there's no conditional structure, is there? Questions? All right, moving forward. New keyword, match. What are we trying to match? Well, we're trying to match reply. Well, what about if the person typed in a leading capital letter or their caps lock were on? Do I care? The answer is no. So I'm going to take what they've typed in and I'm going to run it through a lower function to make it all lowercase. Now, match is a data structure. That means that line 18 must end in a all at once.
Colon.
And when I hit enter, I'm going to get an indentation because that marks things that are inside the structure. And now I'm going to write a bunch of case statements. So in case, what reply is set equal to is JavaScript. Another container, it ends in a colon, and therefore I will print something appropriate. You can become a web developer. Sure you can. And it decided, I'm not sure why it decided that I was done with the case, but it did. All right, the next case is Python. And I'm not going to type all of these. It's tedious. I'll just copy them. So the next case is Python. Now we might as well copy this, put it over here, make sure we haven't screwed up our indentations, which we have. Python, it says you can become a data scientist. I didn't write this one, somebody did. And they capitalized it. We can do the rest of them. But let's just do another one or two that are interesting. There are two languages up here that I would not be surprised if you never heard of. Anybody heard of Fortran or COBOL?
I think heard of, but that's about it. And I think
Okay,
Ben has.
I've heard of COBOL. Isn't that like a really old language?
yes. And so is Fortran. They're both approximately early 60s is about right. The difference is that COBOL was focused to the business programming aspect. Fortran was focused on science and engineering. So the science people thought COBOL was the stupidest thing ever invented. And the business people said it does a beautiful job. And who would ever understand Fortran anyway? So, so be it. Both of them are old. Does that mean that there's no code out there that running anymore that uses either Fortran or COBOL? The answer is that's not what it means. There are people who are too lazy or too poor to pay somebody to come in and rewrite code from the 60s, 70s, or 80s. So they run it. So we're going to claim that if you know Fortran or COBOL, you actually might get a good job. That's possible. And I did something here I shouldn't have done. I've mixed my quote styles. Bad, bad, bad. Don't do that. The PEP 8 standard says you can use one or you can use the other, but be consistent. And my consistency tends to be in single quotes. So you don't want to imply anything by changing your mind in between. So let's talk in English. What we're going to say is that you can get a job working on legacy software. Well, that is true if you learn either Fortran or COBOL. Well, gosh, either or operators sounds confusing. Well, it doesn't have to be if you embrace match case. You can say Fortran, or COBOL. Now that I've got those double quotes in my mind. And that's the case. We'll put our print in here and say you can become, or you can get a job working on legacy software. And just to take time out to tell a little story, particularly with COBOL, this became a whole big deal around the Y2K stuff. Since a lot of the COBOL business software was running businesses and a lot of it hadn't been touched, people got very concerned about what would it do when we went from December 31st, 1999 to January 1st, 2000. So people who knew COBOL in particular made a bunch of money going in and auditing old code and trying to find cases where somebody had screwed something up and modifying it so that it wouldn't crash. I think the result was very few issues came up in that transition in spite of the dire predictions that the world was going to come to an end. So on January 1st, 2000, my daughter was a junior at college on a junior year abroad trip to Zimbabwe. And at that particular time, she was living with a family in a rural area of Zimbabwe where they had no electricity and they were washing their clothes by beating him on a rock. They were not worried about Y2K. That was not a concern of theirs, what was going to happen when old programs rolled over. Their rivers still flowed and the rocks still worked, and they would still get their water out of a well. Okay, now I don't want to take the time to write all the other cases. I have an example of them. I could paste it in here. But what about if the person picks a language that's not on the list? What are we going to do? Well, we need a default. Well, how likely is it that Python would have ignored that fact? Not likely. They've had plenty of years to think about it. So they decided on a convention like this. This is our default. The underscore in Python is hidden in several places. It is a valid variable name, but it's taken to mean I need a variable here, but I'm not going to use it. And you can actually use it in a for loop, but that's out of the case. In this case, the case is they typed something in that you didn't recognize. But we don't want to give up all hope. So we're going to write the language doesn't, apostrophe. Okay, so if I'm putting an apostrophe there, then I better put a double quote over here. The language doesn't matter. What matters is solving problems. Okay, closed double quote. Okay, so we've got a green check mark, yay. We've got a multi-way test. It's not finished, but good enough. We've got a multi-way test without writing ifs and elifs and elses. And the variable that we're interested in, the variable that we're matching, only needs to be mentioned, well, okay, only needs to be mentioned here. So when you write ifs, else, ifs, you need to say what is it that you're comparing. When you write a match, you say match on this expression. In this case, the expression is a string variable. How do I know? I hover over reply, and it will tell me that it's a string. So it's matching based on a string variable. Just in case, I'm going to convert it to lowercase. And then in my case statements, I'm going to match the reply to a bunch of strings, and I should finish this up. I'm going to use the vertical bar to mark an or. So this says, in English, this reads, in case the person typed in Fortran or COBOL, let them know that they can work on legacy software. And if they're in the right place in the right time, they can make a lot of money working on legacy software. Now, I could have put other languages up here that are so dead that you could still learn them, but you should probably print good luck getting a job. But you never know. Okay, so let's see if this runs and go from there. All right, so hopefully we're down here. Here are some programming languages you might be interested in. What language would you like to learn? Of course, we want to learn Python. You can become a data scientist. One and done. There's no looping here. And there's also not a lot of validation other than the default case. So there is a valid language called APL that very, very few people learned. And if I type it in, it'll say the language doesn't matter. What matters is solving problems. All righty. So there it is. I thought that I had put a section on match into D2L, but it probably never got picked up in the template for the course. So I'll be egotistical enough to say that you may be one of the few classes to actually know that a match statement exists. And it's cool. And when you get to do Java, for those of you who will do Java, look for a switch statement That's pretty much the same thing. Switch statements have gotten smarter and smarter over the iterations of Java. So there are ways of doing different things. I think switch statements might allow you actually to do range checks in here, but anyway. So there we are, match on something, and then run multiple case statements. And then at the bottom, have an else case underscore. Notice the colons, notice the indentations. So hopefully now everybody is really firm that if you are in Python and you are a software container, that you start with a keyword, you do something, you end in a colon, and then you use indentation. Okay, so how are we doing? Not bad. All right. Questions? All right. I'd like to get ready to do a break, but I'm not quite ready. And I would like to, after the break, give you a half an hour to work on a breakout. These are not punishment exercises. The breakout is an opportunity for you to work together with a peer instead of listening to me and figure stuff out. Now, if that stuff is easy and you can figure it out in 10, 15 minutes, great. If it takes you a half an hour and you're not quite done, that's okay too. We will come back next time and look at, I think, 3 different ways of doing the breakout exercise. So immediately after the break, I will clue you in on what that exercise is. So let's take a breath. And let's get back to the beginning. And let me just take a quick drink. So what I want to spend about 10, 15 minutes talking about is the final project. You should remember, because it's important that you do, know that the final project is worth 20% of your grade. So if you blow off the final project, your baseline is 80. You can only go down from there. I don't know that I've ever had a student who didn't do a final project who passed the class. So why don't you just take that as being valid experience and assume that if you don't do a final project, you're not going to pass the class. So what does that mean? Well, one of 2 things in my mind. It either means start working on the final project or decide if you want to fail the class, or do you want to drop the class and have it not appear on your transcript. So if you drop the class, if you withdraw, then you will get a withdraw on your transcript, not an F or not a U. For those of you who aren't familiar with it, a U on your transcript basically means you didn't do enough work in this class to merit an F. It's not pretty. Or you walked away from the class without formally dropping it. So I don't want to sound depressing on what's turning out to be a sunny day, but that's the truth. So do with it as you may. So let's go take a look. And as we talk about final projects, we notice that there's a whole module devoted to final projects. And in there is another link. Okay. So what do we expect in the final project? Let me keep track of time so I don't get too carried away with it. What do we expect in the final project? We expect something graphical. You're going to learn more about GUI 0 than any other graphics library, but there's other things that you can do. So there's an underlying library to GUI 0 called tkinter, old as the hills, and a few other ones like PyQt that I've not used that are available to you. They all have different flavors to them. tkinter has the same flavor as GUI 0, but with a lot more detail and more capability. It makes it harder. There's another graphic library that some students have done very well in a final project called Turtle. Turtle is built into Python. You don't need anything external. You do need to import it. And it also uses tkinter behind your back, but it presents a very different kind of look and feel. So in your project, we want you to make sure you use variables. Well, duh. Some kind of collections, some kind of conditional, some kind of iteratives, and one module that you've explored on your own. In other words, this should be something where you learn stuff. And it should also be something of substance, so that your final project is not something that you can successfully do if you start 2 days before it's due. So we've given you some, oh, I got to take something out of here because I don't like it. We've given you some 14 ideas as to what you can do, but I'm going to make it 13 because I'm going to take one out. And I don't know that it pays right now to go through these. I think what I'd like you to do is I'd like you to read through these things and then ask questions over the next 1 or 2 or 3 classes. So Vote 2021 has to be updated. But they're projects, most of which have been done before, that students have done successfully. Some of them in class, some of them are students who I work with outside, but they've been done successfully. Okay, now and number 15 is bring your own idea. We don't want you to be limited by our list. If you have something you'd like to do, then propose it, and I'll make a judgment about whether it's an acceptable idea or not. Brings us to the next question, which is, what is not acceptable? And these are 2 examples. Basically, they're things that have been done so often that I feel there's nothing else that you're going to bring to them. So quiz games that just have text built into them versus reading them from a file. Digital clock is pretty trivial. Another one is there's a game called Snake that's been done a gazillion times before. I didn't know that until a student proposed doing it. Tic-tac-toe has been done a gazillion times before. Pong or ping pong has been done before. There are solutions out there, but it was amazing to me when I started looking. Whoops. Hey, if you can hear me, something happened over here. I lost my picture.
We can hear you. Can you hear
Oh,
us?
you can hear me. Cool. Interesting. It looked like the CRT. Or the CRT. Yeah, it looks like the display is not doing it. You can hear me. Okay. So I will finish talking and then we'll do a break.
All right.
Or yeah, I don't have another screen. We gave our other screen away. Yeah, ping pong as a game. I started looking at solutions and I was amazed that they kind of missed a point in the solutions that I saw. So if you are intrigued by that, we can talk about what you could do. So if now the light came back on, and the screen came back on. Oh, all right, Tony. I guess you can still hear me. Yes.
Yes, we can.
Yes, thank you. If I see something that I suspect has been done before, I'm just going to Google it. And if I can find the solution, you need to tell me why you're going to do better than a solution that I can find online. We need to do this early because let's take a look. Let's take a look over here. Let's not lose track. I wonder what happened over there, unless something's loose. Let's take a look under assignments and see what's doing down here. So February 26th, we have a proposal. And in D2L, they describe what the proposal should look like. I don't care exactly what it looks like, but I do care that it has enough detail to give me an idea about what it is that you're trying to do. That proposal has to be, I have to accept that proposal to give you the okay to work on the project. So if I don't like your proposal, period, I'll say I don't like it. If I don't like it a little bit, then we'll have a discussion about how to make it something I do like. But you're not on good ground to proceed with a final project until you have the proposal approved. And that will be done in D2L. Then we will do 2 check-ins over the few weeks apart, where we'll get together on Zoom and just say, how are things going? Are you stuck? Are you on schedule? And then you will submit your final project on April 23rd or before, which is the end of week 14, not the end of week 15, so that I have week 15 to grade it, sort it out, and have any discussions that we need to have. So this final project kind of defines the idea that you can't do all your work in the last minute. You have to have a proposal. It's got to be acceptable. You have to show me progress, and you have to have the thing done a week before the end of the class. Okay. So anything that you can think of that is GUI based, I'm willing to discuss with you. And students have come up with some pretty wacky things, and that's cool. The one about the MP3 player I've gotten bored of, and it's a pretty trivial exercise to do a minimal job, so I'm taking that off the list. No more MP3 players. And even an MP4 player, not that thrilled about. Now, in either case, you would have to learn about a library that we haven't covered. And that's part of what we're trying to do. Right, so any questions right now about the final project? Okay, so we will pause the recording until we get started. So if anybody wants to see what the exercise is, they can. And can somebody confirm you can hear me?
We can hear you.
And you can see the board, right? You can
Yep.
see my screen.
Yeah.
Cool, okay. So here it is. This comes out of New Jersey, which at least when I was living there had a pretty dumb idea that different things had to be recycled on different days, and it can't be commingled. So everything had to go out in separate things on different days. And it's hard to keep track. So what we're going to do is we're going to prompt the user to enter what day of the week it is, and then you will inform the user of what needs to be recycled. So Monday and Friday, paper goes out. Tuesday, glass goes out. Wednesday, plastic goes out. Friday, metal cans go out. And Saturday and Sunday, nothing goes out. And then, of course, this was mixed up with garbage that also had to go out, but good enough for one day. So there's the assignment. I've not prejudged how you should approach it. I've not given you any hint about how you're going to store and present the data. That's up to you. As I say, I think there's 3 different ways of doing it. We'll talk in the next class and go through those. But I'm not going to say one of those ways is any better than any other. So in your group, think about what it is that you want to do, how you want to do it, go for it, and hopefully it doesn't end up in a dead end. I would say if after 15 minutes you're at a dead end, you probably have 15 minutes to redo it in a different way. All right, questions about what I'm asking you to do? Does this make sense? Whether you like it or not. So I got a criticism in one of the class evaluations. Your assignments were boring. I'm sorry. What do you want from me? Any questions?